Okay, today we are going to be talking about multiplication properties. So we've already talked a little bit about some multiplication strategies of 2-digit by 2-digit numbers. Today we are going to also talk about multiplication properties so that you have a couple different methods for multiplying numbers. Okay, so you should hopefully already have your notes glued in on pages 28 and 29 in your journal. The notes page is actually on the left on page 28, and your practice should be on page 29 on the right hand side. Okay, please make sure that you are focused, you're paying attention. If I'm writing, you're writing. So you need a pencil in your hand, not an eraser. You probably need pen, something that you can see other than a highlighter. You need something to write with that you can see well in your notes. Okay, so I don't care if you use colored pencils, pens, pencil, whatever you want to use in your notes is fine as long as you can read it really well. Okay? All right, here we go. As long as it doesn't bleed through. I probably would advise not to use that and to use something different. Especially something erasable or something
like this.
Okay, so we have 3 different properties of multiplication that we're going to, or did I say 3? I meant 4. We have 4 that we're talking about today. We have identity, zero property, associative, and commutative. So when we're looking at identity property of multiplication, that means that you can multiply any number by 1, and the product is that number. You can multiply any number by 1, and the product will always be that number. So an example, 4 times 1 is still going to be 4. That is identity property. Think about what the word identity means. Identity, what comes to mind when you think of identity?
Like your identity to yourself.
Like your identity to yourself, true to yourself.
Like your,
okay, yourself.
Like your ID.
Nothing can change you, right? Okay, you are you. Like you are your identity, right? Like you're your own person. So when we talk about identity property, that number is not going to change when I multiply it by 1. It's going to stay the same. Okay? You could go from my class to Miss Amon's class. You're the same person you were just a minute ago. Okay? You don't change just because you go from one class to the other. Same thing with these numbers. The numbers don't change just because they're being multiplied by 1. Okay, zero property of multiplication is kind of like the identity property, but what do you think it has to do with? What's the very first word? Zero. So the zero property of multiplication means that you can multiply any number by 0, and the product will always be 0. So 4 times 0 is 0. Now, when we get down to associative and commutative, you guys have actually seen some of this in your morning work. Whenever we do the math review each day, you've seen some associative and some commutative. Associative property of multiplication means that you can change the grouping of the factors, and the product stays the same. So I can group my factors completely different, but my product is still going to end up the same. What does that look like? Usually it involves parentheses. Okay? So look straight below there. I have an example of the associative property. I have parentheses, 4 times 3, then times 2. It tells me that that should equal 4 times, parentheses, 3 times 2. Okay, well, what do I know about parentheses? Parentheses tell me that I need to solve whatever's inside of them first. Good job. So we're going to practice this method. Okay? If I have 4 times 3, that would be 12. And then 12 times 2. 24. But over here, I would multiply 3 times 2 first, which is 6. And if I look at this, I know that 12 times 2 is 24, but I also know 4 times 6 is 24. So did it really matter which numbers I multiplied first?
No.
No. Okay, let's look at our example with the 7, 2, and the 3. Okay, if I have 7 times 2 times 3, I could say, you know what, I want to do 2 times 3 first. So if I did 2 times 3 first, my problem would then be 7 times 6, which is 42. Well, on the other side of the equal sign, I've already done 2 times 3 first, so this time I can do 7 times 2 first. What is 7 times 2? 14. And then I can do 14 times 3. Oof, 14 times 3. Doing that in my head? Not sure about that, but I could just jot it down right over here. Multiply it out real quick, and I can still see that 14 times 3 is also 42. So sometimes I actually love the associative property because in my mind when I'm doing mental math, that's how I group things together. I pick out numbers that I can do quickly. So for me, I would probably, if I was solving this problem, like if we were doing a number talks here on the floor, and I'm like, okay, come up with all the ways that you can come up with a product. And for me, I would, in my mind, do 2 times 3 first, because that's easy, 6, and I can multiply 6 times 7 all in my head. It's a lot easier than me saying, well, I can do 7 times 2, that's 14, but now I gotta do 14 times 3 in my head, right? I can get there, but it's a lot easier to do 6 times 7 in my head than it is 14 times 3. Does that make sense? So associative property is cool because you have the ability to regroup the numbers however it works best for you, whatever's easiest for you. Okay, let's look at it commutative. Commutative is on the right side. Commutative. It looks a lot like the word commute to me. Do you know what commute means? If somebody commutes somewhere.
Like to help to, like it's all for everyone.
Commute.
Right.
Does anybody's parents have a long commute to work? Yes. Does anybody have a long commute to school? What does that mean? Cameron. Okay, so maybe like time it takes to get from one place to another. Like commute. If I say, man, our commute is 10 minutes to and from school, okay? Or maybe it's 10 minutes to school, 10 minutes away, 20 minutes to and from, okay? Your commute is how long it takes you to get from one place to another. Commutative is kind of similar. The commutative property is the order of the factors can be changed. So think about the word commute. I can commute from work to home, or I could commute from home to work. See how I'm flipping those around? Work to home, home to work. Same two things for you, school to home, home to school. Okay? The order of my factors can be changed, and the product stays the same. This also works for addition as well. Okay, so here's what an example looks like. If I have 3 times 4, it's the same thing as 4 times 3. I just switched my numbers around. So let's practice changing the order and finding the product. So if I have 7 times 4 here, what's 7 times 4?
28.
28. Well, what's 4 times 7?
28.
28. Does it matter which one I put in front of the other? Same thing. What's 3 times 9?
27.
What's 9 times 3?
27.
Very good. Okay, down here I have a couple of examples of identity and zero property. What's 9 times 0?
0.
What's 8 times 1?
8.
What's 7 times 0?
0.
What's 3 times 1?
3.
Okay, we're gonna kind of recap real quick. Oops. Associative means change group. Associative is when you have maybe more than 2 factors. Maybe you have 3 factors. Maybe you have 4 factors. And you change the group or the order, how you group certain factors to make it easier on yourself to solve for the product. Commutative just means that you're changing the order. You're flipping the numbers around in which order you multiply. Associative is groupings. Commutative is order. Multiplication properties are tools that make finding the product easier. Okay, let's look at our practice page to the right, on the right side.
Can we keep on using?
Number 1 says, with the associative property of multiplication, when the grouping of the factors change, the blank stays the same. What stays the same?
Product.
The product stays the same. We're not talking about addition, so sum is way wrong. Okay, multiples, yeah, multiples have to do with multiplication, but we're not listing the multiples of certain numbers. We're not listing factors of certain numbers. Number 2, Josiah wants to solve 5 times 9 times 350. Choose the property that lets him rewrite the problem as 5 times 9 times 350.
Associative.
Very good. Associative property. Good. The way I always remembered associative property, meaning groups, is sometimes you associate with certain people. So like maybe you don't hang out with everybody in this class, like outside of school.
But
Maybe you associate with like just a couple people outside of school. That's kind of like your group outside of school. Or maybe you associate with your soccer friends at soccer practice and soccer games, but you associate with like baseball or maybe cheer friends at different times, or maybe you associate with church friends. So those are your different groups that you associate with. Same thing in math. The associative property is the groups, okay? All right. Number 3, which shows a strategy to solve 9 times 26. I just want a strategy. How could I solve that? Ooh, somebody said C. Why, Braden? Can you explain? You're right, but why?
Because it's easy.
Why is it easy?
Because
Well, let's look at A. Okay, if we're just doing process of elimination to figure out, well, which one could actually solve 9 times 26? If you look at A, 9 times 20, could that work? That could work. But could I add it to 2 times 6? Why would I do 2 times 6? That's like 26. Okay?
it's the 6 and the 20.
Yeah, that doesn't work. So I can't do 2 times 6. That does not work. Okay, what if I did 9 times 2? Well, what is the value of 2 here?
20.
It's in the tens place, so it's worth 20. If I did 9 times 2, I would be multiplying it by 2 ones, not 20, okay? And if I did 9 times 60, it's basically like if I were to have this instead of this. Because how many tens do I have here? 6, which is 60. So that's what this is representing, which is wrong. Okay, C, it's a lot like our area models that we did the last 2 days. Okay, so maybe some of you weren't like associating, oh, there's that word again. Maybe some of you weren't associating our area models to this particular problem, but that's exactly what this is.
But you split the 20 into 6.
Yes, I'm breaking the 20 apart into expanded notation so that it's like 20 plus 6. So I take the 9 and I multiply it by 20, then I can add it to whatever 9 times 6 equals. So C is the correct answer. D can't be right because that's way too much. I don't have all that anywhere. Yeah, I have 26, but I have 16 nowhere. Okay, today you are going to have a practice page on commutative and associative property. Then, if we finish early, I will see if I can either find a quizzes that we can do together or maybe a Kahoot that we can do together, okay? I may post the quizzes in Google Classroom so that if you finish your worksheet early, you can go ahead and get a jump start on that. And then if everybody's done, we'll do something whole class, okay?